Hello everybody, in this video we will be exploring 3 different ways to evaluate a function. We have an example problem here that says consider the function f of x equals 2x minus 1. Evaluate the function f of x at the values x equals -1, 0, and 2. And so we're going to evaluate this function f of x, but we're going to evaluate it 3 different ways. We're going to evaluate it the typical way that we would by just plugging in values into the function. We're also going to evaluate it using a table. And we're also going to evaluate it by reading a graph. All 3 of these examples serve as different representations of our function f of x and different ways that we can go about evaluating the function. So let's start just by plugging in these values. If I want to evaluate the function at these 3 values, of course, we have to do one at a time. I'll start with -1. When I'm done with -1, I'll go and I'll do 0. When I'm done with 0, I'll go and I'll do 2, and so on. But we'll start with -1, which we have right over here. So f of -1, if you notice, f of -1 is the same symbol that we have right here, except with a -1 inside of it. What does that mean? That means that we're setting x equal to the value -1, which in turn means that wherever we see an x, we can substitute it with the value -1 because they're equal to one another. So I'm going to rewrite this function here. It says f of x is equal to 2 times x minus 1, but I'm going to replace all of those x's with a -1. And it's no longer going to say f of x, it's now going to say f of -1 is equal to 2 times, instead of 2 times x, it's going to say 2 times -1. And then we still have this minus out here, so I'm just going to go ahead, if it doesn't change, it stays the same. And there we have it. All we did was rewrite this function here with -1s instead of x's. That's all we did. And now we have to simplify, of course, using the order of operations. I know I multiply first, so 2 times -1 is -2, and that gives us -2 minus 1, because this -1 hasn't changed yet. And then, of course, that just gives us -3. Cool. So I know that when x equals -1, my function is equal to -3. I know that when -1 goes into my function, -3 comes out. Nice. Let's continue and do the same with the other values. We can just do these pieces somewhat quickly. So when x equals 0, we see that the function equals -1. And last but not least, 2 times 2 minus 1 equals 4 minus 1, which equals 3. And so I see that when I put in a 2, I get out a 3. Okay. And so I evaluated this function at 3 different x values and got their outputs each time, as we see. Let's also try evaluating this function just by reading this table that we see here. So I took it upon myself to highlight the specific values that we're trying to focus on. I know that I'm dealing with x equals -1, 0, and 2. And so I highlighted my -1, my 0, and my 2. And so we should all know that when I'm dealing with a table, these are my x values that go into the function, and these are the corresponding y values that match each x value. And so these are also coordinate points, of course. So this one can be read as the coordinate point -2, -5. This can be read as the coordinate point -1, -3. But the main thing we're trying to understand is the fact that when I put a -2 into the function f of x, I get out a -5. When I put in a -1, I get out a -3. So the table told me that if -1 goes into my function, that -3 comes out. The table evaluated it for me. All I had to do was learn how to read the table. And so I see that f of -1 equals -3 according to this table. We can do the same thing with my other values. So I also need to evaluate it at f of 0, where x is equal to 0. And f of 0, well, when 0 goes into the function, what comes out? Well, -1 comes out. And so I see that f of 0 is equal to -1. And last but not least, f of 2, we see f of 2 returns 3. And so we get the same values that we did before, of course, because it's the same function, just being evaluated in different ways. We evaluated it algebraically, because that's an important skill to know how to do. We evaluated it by reading a table, because that's even more of an important skill. Maybe less. And then now we're going to talk about evaluating it on a graph. So knowing how to read a table is equally as important as knowing how to read a graph. It's the only way that we can analyze some of the behaviors and patterns in our functions, especially as they go on and on and on towards infinity and beyond. And so we just want to know how to read these. So a graph, of course, is just a bunch of coordinate points. We have 3 coordinate points that are highlighted here to make up this line, but realistically, there's an infinite amount of coordinate points. There's one right here, and right here, and right here, and right here, and right here. All around there's coordinate points. And then in between those points, there's more points. And in between those points, there's more points. That's how we actually get the line, is an infinite accumulation of points, just one after the other, right next to each other. And regardless, we're only focusing on these 3 points. Why are we focusing on these 3 points? Is of course because these 3 points give us the y value when the x value equals -1, 0, or 2. And so this graph here, as with every graph that's a relationship between x and y, it relates the variables x and y. I can see for every single coordinate point that for some x value that it corresponds to, it has some y value. Some unique y value as well, because these are functions. I see when x is -1, we're here on the x-axis at -1. And where do I meet my graph? So along -1, here I am, going along -1. Where do I meet my graph? Well, I have to go down to meet my graph. And when I do that, I get to this point right here. And where's that point? I see that it has a y value of -3. And so what does that tell me is that when I take my function, I put that -1 in there, then I get out -3 on the y-axis. And for those of you wondering why I keep interchangeably using f of x and y and f of some number and y and so on, is because, of course, we should always know, no matter what math class we're in, that y and f of x represent the same thing. They represent our equation rule. The only difference between the two is that f of x tells us a little bit more information than the variable y would on its own. F of x also tells me that whatever equation we're dealing with happens to be a function, and so that's why we use that notation, but it's just a variable and it happens to be the y variable. And so I can say f of -1, or I can say y when x is -1, because they're the same thing. Okay, but anyways, I also need to know f of 0, aka y when x equals 0. And so I go here, I'm looking for where x is 0. Of course, x is 0 at the origin. And so I'm here, I'm going along the y-axis, and I'm looking like, where do I meet my graph? I meet my graph here at this point here. And what do I see? I see that that value is at -1. This picture is getting a little messy. Let me just clean it up a little bit. But yeah, the value is at -1, and so f of 0 equals -1. When 0 comes in, -1 comes out. We can do the same thing for the 2. These are slightly off just because I drew them by hand without a ruler. But I see that I have to go up to get to the function. I get there, and when do I get there? Is when I'm at the value 3, the height of 3. And so that tells me when 2 comes in on the x-axis, when x is equal to 2, y is equal to 3. So the function at 2 is equal to 3.